Now, next speaker, Mr. V. Sashira Rao, a highly experienced professional with experience, 15 years experience in the solar design and construction and telecommunication industries, over 3 years experience in the international procurement, 9 years in the solar industry, in the nearly 100 megawatt of grid and off-grid project, and 3 years in the telecom O&M. Professional experience, manager, project engineering and procurement, renewables, Kirwins LLC, Houston, Texas, October 2021 to present. Educational profile, Master of Technology in the Digital Electronics Communication VTU, Karnataka. Bachelor of Engineering, the Institutes of Electronics and Telecommunication Engineering. Professional achievement, members of Institutes of Electronics and Telecommunication Engineering. Professional experience working for Kirwins LLC as a manager, project engineering, procurement, renewables, hostels, October 21 now till date. Work for the Lotus Energy Power Solution Private Limited as a general manager, project engineering and business development, November 15 to September 21. Work as a Premier Solar System Private Limited at Hyderabad, general manager, project October 12 to October 15th. Now, sir, please start your session.
Yeah, can you hear me, listeners? Anyone can you respond? Jeanette, can you hear me?
Yes, sir.
Thank you. Okay. Being a professional with respect to solar industry for about 8 to 10 years, specifically I can say that, what are the developments which are going on nowadays with respect to the panel, with respect to cell, and with respect to the design culture to maintain a good productivity in the sense, to catch up the efficiency and also to understand to tap the energy to the maximum extent, which our prime criteria is. So let's start with my presentation. Can you see my screen, sir? Hello? Yeah, can you see my screen? Anyone tell me?
Yes, yes.
Yes, thank you. Yeah, innovations in solar energy technology, right? So that's one of the topics given to me, with breakthroughs and future potential also that to discuss with. So, yeah, to start with, solar energy, harnessing the solar sun's power is a cornerstone of the global shift towards renewable energy sources. So, see, energy, it's diminishing, right? So it's like fuel, fossil fuels and everything. So even oil, to some extent, in one of the countries, in the African countries, where they definitely use generators to get the power then. So there's all this diminishing one. So it's only the sun which shines all the day, in the sense, the sun hours, you can say that. So that's where we want to tap this solar energy to the maximum extent. So that's where the innovations have gone through in a major extent. I can say from the 4 decades, mostly from the 4 decades, right? So ongoing innovations in solar technology are continuously improving efficiency, because the efficiency factor is only the main thing which we want to highlight on. And by reducing costs, because the cost cannot be higher with the materials we use to generate the panels or the cells, and to manufacture the panels and everything. So reducing cost is also one of the most criteria in it. And expanding the potential applications of this clean energy source also. So all these 3 points, which I will definitely stress on by understanding, by giving you what are the research which is going on with respect to the cells and panels and other construction activities or in the full field, because being a person who has hands-on experience in designing and executing the projects as well. So I'll definitely give some points to what best we can do to enhance the production, to consume the production of the power, and then understanding more deeper into it. So the key areas of innovation which is going on should be, as I say, that it's advanced solar cell technology, enhanced solar panel design, and what kind of other designs which we can use to tap the sun to the maximum extent, and concentrated solar power advancements also that's going on as ESP. Then smart solar and grid integrations, and not only the components which we use it. So it's all of that how best we use it is also one of the things which we have to stress upon to understand the technology, understand the design point of view on each side. So to start with, and yeah, advanced solar cell technology, if you can say that one of the topics on it. So this is the apart from amorphous silicon and polycrystalline formed of polycrystalline monocrystalline cells, which the world have used for last decade, if you can say that last decade and a half. So most of the solar plants of 80 to 85% plants have been installed with amorphous silicons, monocrystalline, polycrystalline silicon tapped based power plant. So in order to go a step ahead to tap this, because that's efficiency of the panels of those silicons have started from 12%, 12 or 10% to at times it has touched around 20 to 23% as of now, with respect to the monocrystalline silicon based panels. So if I go a further a step ahead, so if we can understand that what is perovskite solar cells, what is multi-junction solar cells, what is silicon heterojunction solar cells. So if we can understand this, so that the efficiency levels and the process by which they are manufacturing it, the research is going on in this particular kind of cells, where the interest will be more because the efficiency is outbound, because it has increased from 30 to 44% to some researchers. They outrightly say that, yeah, I can say that it's 44% efficiency I can catch up on in another 4. So that's where I want to stress upon, because my any of the topic says that breakthroughs future potential. So what are the breakthroughs in this? So for expect solar cells, I think 2025 from one or 2 points were plants which are already installed in USA, and the Japan and China I think is already been installed. I think the research with respect to the monitoring is going on there. So how best the production results, all the plant results will come up, and then they understand that what is the difference with respect to the percentage which we are coming up, the power production and everything. That will catch upon that. Of course, in another 2 years or 3 years, we'll come to know about the best what the best it has given to the world. So these cells utilize a hybrid organic inorganic lead or tin halide based material actually. So offering potential for higher efficiency and lower manufacturing costs compared to traditional silicon cells. So perovskites, I'll just explain what kind of formation is perovskite cell is all about. And multi-junction solar cells, because by combining different semiconductor materials, these cells can capture a broader spectrum of sunlight. Yeah, broad spectrum of sites. Sorry. Yeah, broader spectrum of sunlight, leading to increased energy conversion efficiency. So another form of type of solar cells which we wanted to use it to increase our efficiency levels. And even silicon heterojunction cells. These cells combine crystalline silicon with thin layers of amorphous silicon, resulting in improved efficiency and performance, particularly in low light conditions. So this is also one of the criteria where the light is low, and then what best we can use it. So these are the 3 major types well, because so many researchers going, but I have tapped on these three to understand more into it because they've already wanted to get into this world with power plants, installations, and everything in the next 2 years. So, how does perovskite solar cells looks like? You can see that what is the combination of it. So, one is a to understand the whole conductor electrode and transparent conductive oxide is also there in between. There's a conductor. So, perovskite is the crystal-like structure, right? So just like a diamond crystal-like structure, which the formation goes off. So how does this absorb light and generate electricity? So PSCs, short form, we can say that, so are made up of layers of materials that are coated or printed into a substrate, onto a substrate. So these are coated, printed onto a substrate. How does they work? They're exposed to sunlight. The perovskite, the PSC absorber layer releases electrons. So the electrons move to the whole transport layer and then to the conductor. The conductor powers the connected load. So this it's a complex crystallized structure as peroxide cell is all about. So that's where this initial electricity with excitation of the electrons. So what are the benefits of it? So if we can, I can deeper into it. If you can go deeper into it, then I have to understand the structure of it, how does it looks like and everything. But I'm in a broader sense, I'm just touched upon. If you can go with the benefits, it's with respect to the solar streams, because whenever we're comparing, we compare with the 80% of the installation which is already done in the world, right? So it is amorphous silicon or silicon, monocrystalline, polycrystalline silicon cells and everything. So with respect to that comparison, if you can say that it is cost effective, because the manufacturing of solar cells can be produced inexpensively at lower temperatures also. And efficient. These are very efficient, actually, are more efficient than conventional silicon solar cells. More efficient, right? And that's what we have targeted for. So, right, 33% they say that as of now. I think it can has a bandwidth of increasing up to 42 to 44%. So there is a research which the professor or the assistant professors which can think of to understand this crystalline structure and then go into the research work as well. So it's can be designed and manufactured in a variety of ways. What are the challenges of it? So this is the challenges. See, operation timelines and long-term stability issues. So this is when this is exposed to the oxygen, when it's exposed to other atmospheric conditions, this is prone to get a degrade. So unlike the silicons, that's where the challenge is. So this hardness, the perovskite, whether we can fix, whether we can mix up with some other material to get it harder and to get this material to be prone or to withstand all the conditions, atmospheric conditions, so that it can last long. That's where the point the perovskite is lagging somewhat here and this. So still ongoing research is focused on improving the stability and efficiency of the PSAs. Yes, so there still research is going on, and this is one of the areas where most of the worldwide people are thinking on that. So next, if I go to the multi-junction solar cells, so that utilize multiple PN junctions here. If you can see that NP, 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 that's right, the combination of NP junctions made from different semiconductor materials. So why this? Why this efficiency is getting increased is the cells, the multi-junction cells or the perovskite cells, perovskite cells, PSC cells, what we use, they will tap on the different wavelengths. That's where the efficiency of it's getting broader, it's getting higher. And also the timelines of the sun hours, because normally we calculate the sun hours as 6 sun hours, 6.5 or 5 sun hours, and average we could put together. So that is if we can tap for more hours, morning another 1.5 hours, and evening another 1.5 hours with a lesser lower light, then we can just generate some more electricity of that. So we can add some units to it. That's where our main intention would be, because see, we cannot sleep overnight and then we can for only 4 or 5 hours generate electricity, investing more on the installation costs and everything. So investing most on the projects and then coming up with only 4 to 5 sun hours a day, because it's only the 20% of a day of hours which we are generating it to the max. But it can see it can be 6.5 hours or 7 hours in summers. It can be 3 hours or 4 hours in winters. So that's where in average we can say the 4.5 hours, 5 hours. Normally it depends on the region to region of the sunlight productivity or sunlight irradiation levels. So this multi-generation solar cells absorb wider range of wavelengths. By this idea of understanding this, because see, each NP material is different here, because the top cell might be made of gallium indium phosphate, which captures blue and ultraviolet light. The middle cells could be composed of gallium arsenate, which absorbs green light. The bottom cell is typically germanium, designed to absorb infrared light. So several researches are going on different. See, not only this top cell, middle cell, bottom cell. It can be used for several cells also, right? NP junctions can be multiple. Like I can go for 10, 12, 13. So by the compositions of the material, what kind of wavelength you're tapping at. So we can see here, you can see my cursor, but this is the wavelengths which have gone through. So the tapping of these wavelengths definitely gives you more electricity on lower lights. That's the intention of the multi-junction solar cells are. So the key points would be then it can be a higher efficiency, specific portion of this light spectrum. So tapping of the light spectrum, allowing for better utilization of the entire solar radiation. So higher efficiency due to their availability to capture more light across a broader range of wavelengths. So multi-junction solar cells can achieve significantly higher efficiencies than single junction cells. So this, because of the combination of this, but the choice of the material selection is also important. See, this is not fixed. So how best you are using the bandwidth of it. The top junction, the bandwidth is 1.7 to 1.10 volt, and the middle junction is what is it, and bottom junction is how much. So all these things, what light do you want to tap upon? These all things. So like this, that's where the research has touched upon. So not only three, as I said, it's not only three NP junctions, but it's multiple NP junctions also can be used. So while highly efficient, multi-junction solar cells can be more expensive to manufacture than single junction, so due to the complexity of the design and fabrication. So this is where the complexity has come into picture here. So if it is complex, then the cost of manufacturing the cell, definitely it will be more. So that's that's where this is research and the cost effectiveness. That's always fights together, right? So whenever the cell is good or bad, or then it's not working fine, why it is not working fine, then they do researches on that. But the multiple multi-junction cells, so the perovskite is also the material which is available in the world for the lesser price and everything. It also depends on that. So definitely, it's all the debate is always open with respect to this. How if from 15 efficiency to the 35% efficiency, if you're increasing the tipping index with 125%, so how much amount you're going to spend for that, right? So it's also more important in understanding that. So cost reductions is also one of the criteria, and the material which is used for each junction is also getting is researched upon. So design, and what are the applications in this multi-junction solar cells? See, all the space applications are used multi-junction solar cells. If you can see a good figure of a solar cell on the sun, a satellite, or on a space application, this one space, and you can see that solar cells spread on the wings. So those solar cells spread on the wings of the multi-junction solar cells, well suited for use in space where high efficiency and reliability are critical. So we can reliable on more on that. So these cells are also used in the concentrated solar power, which I'll also touch upon in the next slides. Can be used in concentrated solar power systems where sunlight is focused onto a small area to achieve even higher power output. So this multi-junction solar cells are also there, used in such applications. So another topic which we can go, silicon heterojunction cells. So this is also which are one of the topics which we have to talk, because with respect to the heterojunction solar cells, the cost is more. Then this is another area where we can understand, we can go for this huge manufacturing because of the less price than the multi-junction solar cells. So that is heterojunction solar cells with intrinsic thin layer. It has an intrinsic thin layer, or HJT, it's called as HJT solar panels, or a type of photovoltaic cell that combine crystalline silicon and thin film technologies to achieve high efficiency. So if we can understand this, silicon, crystalline silicon and thin film. Thin film is also one of the technologies, because it's combination of that's crystalline silicon and thin film, which is already which is already there in the market. So we are making use of those cells and combining it together to get this efficiency, to increase in the efficiency of the panels. So the structure, depositing. So this, how does it looks like? So see, solar cells. So there's the combination of this compositions on this n-type amorphous silicon, this grid lines, and then transparent conductive oxide here, and p-type amorphous silicon has also been part of it. So this different combinations will have an different naming. Passivated, say this PERC solar cell also it's in the market actually as of now. The PERC solar cell also in the market. So it's a mono PERC, it's called as. So I think from 3-4 years, I think people have been using this. And tunnel oxide passivated contact top solar car cell, so top one solar cell, it's called as. So and then integrated back contact solar cell. So these kind of solar cells have been getting manufactured as the silicon heterojunction cells, and then depositing thin layers of non-doped amorphous silicon on both sides of an N-type monocrystalline silicon wafer. So not to go deeper into this technical aspects, I'll definitely make you understand that the efficiency is more than 30% for bifacial models. And see, now the efficiency has touched upon 26 to 28% nowadays in the market, as you can see in this. But if you can use for bifacial models, I'll also show you what are bifacial models. We can touch more than 30-32%. So what are the applications of it? With limited space or large generation capacity requirements, they are also being developed for use in vehicle integrated photovoltaics. So most of the vehicles, I think, if we can see in the next decades, right, solar, I think this kind of cells can be used in the vehicles also. So replacing silver with copper for the electrodes and could reduce the cost reduction. Also one of the criteria where the research is going on for the electrodes which you're talking about now, which we can replace with copper for electrodes, could reduce the cost of SGS solar cells. Is also one of the main points which people are thinking of. So next week we'll go for the cells. So these are the 3 cells where I have selected it, but most other kind of cells are also getting researched on that. But I have selected this because of taking considerations with respect to the mass manufacturing, the cost effectiveness, and the durability. At least because when you install a power plant, at least it has to withstand all the atmospheric conditions for 20-25 years. So which I've taken this 3, and in applications with respect to other areas as well. So space in vehicles, and also in the ground, because even the land is also that it's here it has become the costlier, right? So how best we can use the land to tap more energy. That's also one of the criteria which I've selected for 3 cells. So coming back to the seed, there will be, as I explained earlier, that there will be cell, there will be panel, and there will be components of the plant, where all these 3 should combine, and I should come up with a design prospect so that we can achieve our goal of generating more electricity with cost effectiveness, and using all this nowadays, the IoT, Internet of Times, and then are also this. If we can even EA also can place vital role here to maintain a plant. So all these things will add up on to have this solar related uh, business models to increase and to tap the energy which is free free in the world. So bifacial solar panels is one of the panels which we can regular um, conventional models you might have seen, right? So I think it's an angle design with respect to the latitude what we do it, and then it's in standalone and with an even 360 degrees rotational panels, and single and multi, and then 180 degrees rotational panels with respect to the sun, and all these things that just come up. So if apart from that, if we can use some panel design, the different panels, right? How we can use to tap more energy, because the energy yield, what we call with the bifacial solar cells panels, is around 30% and more these days. So even we can use the transparent and flexible solar cells on our roofs, on our patalas, on our verandas, and where the exposure to the sun is more, on your penthouses, where we can tap upon this. So that's also one of the areas where the research is on. Because see, that's where, because most of the people will definitely cover a sheet, right? So if you can cover with a solar sheet, then it adds up to your aestheticness and also to to generate power. So that's also one of the areas which the people are highly motivated or highly interested to work upon. So these innovation allows for the integration of solar technology into windows, building materials, and even wearable devices. If you can wear some shirt with respect to that, that definitely it is another one, is expanding the potential applications of solar energy. And people are thinking of the aestheticness of why I'm saying stretching component. There are solar skins also, right? So I'll show the photographs, which how does it looks like. Allows for customization of the appearance of solar panels, making them blend seamlessly with the surroundings and enhancing aesthetic appeal. So this is for solar skin. So this is bifacial solar panels, which I've said, right? So both sides of the this one panels are upward and downward sides. If you can place it on a standalone thing like this, then definitely there will be a reflected light from the direct sunlight, the scattered sunlight, the scattered light, the reflected light. So the even the downside of the panel also can be tapped upon. So that's where the bifacial as solar panels have come into picture. And then this is giving more yield, energy yield, than if I say that monocrystalline PERC models gives you 22% of the energy yield, then it definitely it will cross another 30 to 40% more if you can use the bifacial solar panels. So I was talking about the transparent and flexible solar cell, how that looks like that, right? So these are the transparent thin film, even the solar panel. It just looks like a roof, but it's a solar panel there. So these are the applications which the world is looking upon to understand, right? To tap on, and these are all the research areas. Whatever I'm touching upon, these are all the research areas, and then you can deeply dive and then understand, right, what best we can take it. So if you're interested in solar and understanding all these cells, the panels, and the grids and the small microgrids and smart inverters and everything, they're all the research parts. That so much is going on in different in every other world, in every other main countries. This is what is going on, and this is solar skin which you're talking about. So the color of the building can be matched upon with solar panels on top of the solar panels, and this definitely will not give you if you can go for the bifacial solar panels, and are best used in this bifacial solar panels are best used on in commercial utility scale projects where they can be elevated and angled away from mounting surfaces, allowing sunlight to reflect into the back of the panel. So that's what I've discussed this, but it cannot be used for the residential projects, which is a compact design there, because the space is less, and then you need a more space from panel to panel, or the row to row. so that the reflected light can tapped upon. So I think it is more of a commercial project, a commercial utility scale, higher utilities, larger utility scales projects which can use it. So in this transparent panel looks like a clear glass, but let light through this regular windows. But they are made of with a solar glass that absorbs ultraviolet and infrared light, in specific the wavelengths of ultraviolet and infrared light, types of light that aren't visible to the naked eye. So these lights are not visible to the naked eye. If you can see the ultraviolet and infrared band, you cannot see that. So then turn these into renewable electricity. So this definitely is in it's a very good understanding of this transparent and flexible solar cells to get into the Indian markets and then tap on these kind of things, because might be the cost will be higher at the earlier stages, but when the mass manufacturing will comes into the picture, definitely it will cut down the cost. Unlike traditional solar panels, a flexible panel surface isn't covered by protective glass or metal. This is not protective glass or metal. This is a thin film. Let's just like it can be rolled upon. But these kind of films not only transparent, because see, thin film is used in defense applications where you go to deeper extent to the forest or to the desert areas to longer periods, then you don't have an electricity there, then definitely you use thin film, and that's kind of, you can compare that with that kind of things, but it's more complex and more complicated and a more efficient generated panels like this. So even if you can go with solar skins, right? Solar skins, most of the people in Australia, in America, and also to some extent in UK and I can say in Australia and China, Japan, these people want to use it. They don't want the house to look like a solar panel packed up. So they want to use this solar panel with aesthetics also in it. But this aestheticness cannot compromise on the quality of the what's called tapping of this sun. So definitely, and also that this is helping to see the generation definitely will be the same, but this is also helping in the same manner uh, to tap this one for longer years. So it is protecting, just like a protection, the protecting the top of glass of it, and then making it looks aesthetically also good. So this is also one of the areas where I have where I was searching. Then I just got an interest on that, so to show you. So this is also printed designs and often made to mimic the look of the rooftop. So be it shingles, tiles, or another type of material. The primary objective is to make the panels blend seamlessly into the surroundings, making them less noticeable or obstructive. What sets SolarSync apart from the other aesthetic solutions is that while they change the appearance of the panels, they are designed to have a negligible impact on the efficiency of the underlying solar cells. That's where my point was. So these skins are made of from durable materials and can withstand various environmental conditions, ensuring they last as long as solar panels. So this degradation factor definitely will come down because of the solar skins. Can anyone say, can you hear me, sir? In between. Hello? Hello?
Yes, sir, we are hearing you. Yes, sir, we are
We
hearing
can
you.
hear you.
Thank you.
We
Thank you.
can
Right.
hear
Because
you.
see, the crowd is calm. I understand that. So of course, I'm not getting bored, right? So all well.
Yes,
Yeah.
sir.
When if you can come up to this solar concentrated solar power, another advancements which is going on in this world is the design of solar power plant, right? So what are this? See, they have the advanced mirror designs, improved accuracy and efficiency in focusing light onto a receiver, increasing temperature and efficiency of energy conversion. Why this kind of technology has come? Why? Because see, the sun hours is only 6 sun hours, as I said, 5 to 6 sun hours, right? So what are the rest of the 18 hours? Why you're not using it? Are there any technical way we can add upon or and touch upon so that we can use that also, that those hours also, the most of the 16, because see, I think the if you can say the concentrated solar power advancements, definitely CSP type of plants, they're yielding out around, they're giving out 16 hours. 16 hours they are generating it. Even though the generation, the generation, the peak hour generation and the less hour generation, definitely it varies from hour to hour, but that 16 hours is a huge actually. So when you are investing in a plant and giving you 16 hours of generation instead of 6 hours of generation, definitely it adds upon to your energy, it adds upon to your break even point of view. So this is advanced mirror designs, improved accuracy, efficiency of energy conversion. So thermal energy storage is also one of the areas and the technology which the CSP plans to store heat for extended periods, enabling electricity generation even when the sun is not shining, addressing the intermittency challenge of solar energy. That's where I said that when the sun is not shining, also that you can see the power is getting generated. So this is also one of the areas where this research this is going on. And hybrid CSP plants also, combining CSP with other energy sources such as natural gas to provide a continuous and reliable power supply. So if we can see that, so whenever there is less sunlight, and if we can add another wind energy to it or another natural gas energy to it, so it will become as an microgrid, or we can get a multiple source of power which is getting generated with respect to other renewable sources. Then the 24 hours power supply can be given to even an island, right? An isolated island where you cannot take your electricity or overhead lines and everything to give them electricity for that. So that's where the places where the special interest is going on with respect to this kind of design. So how does it looks like? So how to advance. So even thermal energy storage, we have non-efficient solar concentrators, new designs such as Fresnel collectors and other power sets also. But how does it look like? How to advance mirror design? So what are this advanced designs we have as of now? It's a parabolic mirror design. I have materials and coating design. We have Fresnel reflectors. We have solar power towers. We have. So how does this one taps upon? So there will be a central receiver, which all this will be pointed out to the single contact, so some single point. So all this solar tracking reflectors will be designed in such a way that it concentrates on a single point, right? It will be roundabout. I think I can show that picture as well. So this is one of the major plants which in China this is built up. So this you can see that, right? So the light is getting concentrated to a single point there. So this is where the light focusing on a single point, solar tracking reflectors give you and reflects the light. So this to the light, this functions upon. So that light convert that heats up this tanks. It's in the hot heat tank and cold tank, and then that stores the energy of heat with respect to the molten salt. That heat can be used to evaporate the water and then start the turbine. So like the turbine, and with respect to the turbine, that heat is getting generated, the electricity will be generated. So this is also one of the areas where these installations are going on, because the cost of the material of the reflectors is very less. It's just like glass, right? So reflectors. It's not unlike another combination of the materials. It's not like that. It's not that complex. So this is thermal energy storage is also there. And then if you can come up with the designs part of this, there are parabolic mirror design and materials and coatings design and Fresnel reflectors design and solar power designs. So there will be mirrors which can be pointed out to individual to the one point and then reflect to the main point. And there will be reflectors which can tap the light, and every reflector can pinpoint to a single point. It's pinpoint to the same central receiver there. So that's where the electricity is also getting generated, and this expansion new part. See, this is where molten salt storage, so called government policies also should add upon to it. So that's where my intention would be, because see, if the cost of the power plant will be less or in compared to the same to the solar power plants, why we can't be encouraged this kind of things? Because see, more hours it is getting used upon, right? So more sun hours can be used, or more other light hours can be used. I can't be saying, because in the night also you can generate this. So light hours, it's called as light hours, right? Sun and when it's sun, there is light. So if this moon also, there is a light. So if you can use more sun hours, light hours, then definitely it's just a viable project which you can take it into consideration and then move on. So this is getting expanded into new markets, because gain traction in the regions with high solar radiation and growing energy demands, such as the Middle East, North Africa, and parts of Asia. So this is getting spread out in South American countries also. I think I've seen in Argentina and Peru, and to some extent, the plants are getting installed. This technology makes it feasible to produce electricity even when the sun is not shining. That's what I said. When the sun is not shining, also it's through the tapping of light also it can be used. So other advancements include, right, a wider use of thermal energy storage, improvements in material science. There's also one of the criteria, and that because the storage of heating is also one of the molten salt, which which I said that this is where it's getting stored. Heat is getting stored, and then it is getting converted into a vapor with respect to the water which we flow upon. Then the turbine will rotate, and then the electricity. So there will be some complexes, but in that. But normally, what we generate from the fossil fuels is like coal and then other things, and the water also. When the water produces the turbines, there will be mechanical challenges, definitely, yes. But yeah, this can be. There are so many researches which have been gone through in that, and then this can be a viable project to take into consideration, and also research area can think upon. And what I said, it's key points. What are the key points in thermal storage here, right? Molten salt storage, which I've around upon this the pink figure. Two tanks will be there. There is the hot tank and the cold tank, and then improved heat transfer fluids have to be critical. Installations also should be used while transferring the heat to the operating turbines and everything. So, and advanced thermodynamic cycles also should be used. Grid stability, because of the combination of this, there will be not much variations in the voltage. So the grid stability is maintained all the time. There's also one of the criteria of the transmission of power here. So even dispatchable power, right? It can be dispatched in phases. So whenever we want, we can increase it. Whenever we want, we can decrease it. So this is also because in that solar energy, we don't have that options there. So whenever we have a sun, we have to use it, or we have to spread it, or we have to send it. Whenever there is a sun, we have to give it back to the control rooms and everything. So that's where this kind of technology, I think it has to be thought upon, and also government policies should come up. And yeah, as I said, that hybrid CSP plants. If you can see this is where I was talking about the CSP plant, and then thermal storage and everything. And these are the tanks which can be heat is stored in it, and then it can produce. And these are the solar power plants which is installed around about here. So there are some solar power plants also, which can be said as a combination of the plant, right? So one is say hybrid, then another is solar. So whenever there is we can balance upon whenever there is a sign light, because it's a desert. We can see that the area which we installed it, why they have installed the hybrid, the picture says it all. So this is also one of the good areas where we can think of for the future potential of this innovations and future potential on this. So hybrid CSP plant advancements also, that so there will be thermal storage. See, every topic which I've kept it is on, that's there is a specific research is going on to improve further. So what kind of energy storage, thermal energy storage we can think of, and how are they? So instead of salt, whether other metal can be used or not, molten salt or others can be used. Solid particle receivers, hybrid CSP PSP plants, right? Hybrid, what I have shown that CSP and even PV systems, also combination of it. The modular design, whether how best we can use the tapping of the design, integration with other energy sources also. It's also one of the criteria which we're doing. Fossil fuel switching, also their cost effectiveness also thinking of. So these are the areas where we can see of. So I have started with respect to the cell there, and I have discussed with respect to the panels and how the orientation can be and how that. So I have not touched upon the conventional part here. I'm just talking about the future potential where we can think of to understand, to gain our knowledge and go with respect to the world which thinking of, right? So the people have been always been sticked upon for this silicon crystals and monocrystalline polycrystalline panels, the standalone panels or the rotational panels there, right? So now I think shift is already been into 2025. I think this is the year where you have to use an innovative cells to tap more energy on to get the more efficiency of more than 30% I'm talking about. So this silicon is a stagnant of silicon, right? It will be 28, 29, not more than that as per the technical aspects. If you are going ideally also, it can be tapped upon 26 to 28, not more than that. If the material is also pure and everything. So if you want to increase for more than 30, 33%, I think this kind of innovativeness or this kind of different thinking of the designs which we have to come out with, because even Japan, China, I think China is well ahead of the world, which the way they use, even America to some extent, yeah, they're getting up with the huge, larger plans into picture uh, instead of conventional side as well. So in that scenario, I am coming into the components of it, right? So I've touched upon cell panel and how best we can orient it, and now the components of it. So what are the components which can play a vital role? So these components definitely can be parts. Generation, when you're generating, definitely it should have an inverters to change from DC to DC or DC to AC, in what are the way you use it, and even the microgrids, right? The microgrids definitely will have a controller part of it. So the controller also should have embedded with embedded systems and everything. So microcontroller should play a vital role. And the way you use it, see, every day, every hour, every day will not be the same day for you, right? So we switch on the AC once and we switch off AC once and you use another heater at once, right? So the consumption will definitely will vary with components that you use it. So as long as you're using it, see, if you want only the renewables to be used, then you should have a windmill, we should have a solar, we should have a solar heater, water heater to add up, and then I think integrate with respect to all this, with respect to smart inverters and microgrids. So the controller has to do the job for you, right? Whenever using it in a different, with a different source of generation of renewable energies. So, and in also, why have another added point here in this integration factor, right? Enabling greater integration of distributed renewable energy sources like solar. So even the why I have added Internet of Things, this is where giving, because a person like me giving more data to me to understand a plant. See, for example, I worked upon 2020, 2012 or 2011, the Asia's largest solar power plant, which was installed in Gujarat, right, in Charanka place. That's where, if we can read that for the last, because we have a data of 13 years now, the plant's data of 13 years now, how this component is behaving, how this panel is behaving, how the generation is getting used, or what is the degradation factors we have, because this is the atmospheric conditions of that particular place. And all these things will come only with respect to the Internet of Things. When you are sitting here and then analyzing the data of the yearly data of each year data, then you understand that whether my panel, manufacturing panel, as how much it has given generation of electricity year by year. What is the degradation factor? Whether the degradation factor, the mentioned in the panel, in the pamphlets of given panels, whether this is 0.2% or a 0.3% or a 4% or 5%, right? The data gives you a complete picture of it. Subtracting the condition, subtracting the incidents which will happen in the plant. So that's where the Internet of Things also, I think, in this AI generation definitely will play a vital role now. So innovations should come up in these areas as well, which why there's a huge potential as well. So context of embedded system in a smart inverter. So when you use this, right, when you have a distributed generation system with you, when you use this kind of smart inverters, definitely you can tap whatever the tapped energy can be used properly. So that's my intention was to show it. So generation is to some extent. So research is going on, and you're using the best panels. But how best you're using the power which is already generated there? This is also one of the points which you have to think upon. So this is also one of the play criteria, and researchers are on in it, and then they are also doing it a great job, and uh, understanding the power electronics, and understanding the embedded systems of power quality, protection, and communication. Because the quality is also, because the grid stability is also very important when everyone is generating this with renewable energy, and the grid is not in a position to take it, then the energy generated will be waste. So smart inverters give you increased efficiency, grid interaction, remote control. I think you can control it when on and off, whenever they need it, or whenever this grid is not in a position to accept it, you can stop it. You can remote monitoring it. Advanced safety features. You can even uh, detach one of the inverters which is behaving odd or behaving erratically. In one of the inverters, you can switch off. You can isolate it with respect to your software, and even you can tap on the real-time data. And all this will come sitting in one of the places, and then adding on, and then you see not only this, it's small inverters, this inverters, if it is very smart, then definitely the behavior of the inverters can also be studied, right? So in other sense, we can say that if one of the plugs of the one of the panels, or one of the strings of the plus and minus is behaving hot, so it will not give the same uh, voltage, the same voltage when it is loose, when it is ruptured, when it is rusted, and everything. So if you can study that string by string analysis, then definitely you go to the particular string in the, see, when you have a plant in 50 acres or 100 acres, where do you go and check that whether it is good or bad, or whether it is behaving properly or not? It's only through the smart inverters data only you can think of, and then go and touch upon the same inverter and the same link up, and then change it or unplug it, or you can repair it, and then keep it in and make it happen in the make it ideally work. So that's also one of the areas where you have being an installation guy for 7-8 years in the ground level, I understand this. So what is a microgrid? So this definitely have that, because we should have a UV chargers, and several applications are coming up, right? So even the atmospheric conditions are changing day by day. This summer is not summer, and winter is not a winter. So this, in winter you can see summers also nowadays. So that because of the atmospheric conditions, definitely you should be ready to understand when you are going within distributed systems of renewable energy and everything. So uh, when you want to store it, when you want to detach it, when you want to generate, and when you want to add upon to your things, definitely there should be a controller. There should be a what you call generative AI kind of thing controller, where it understands the same, right? Whenever there is a peak demand, it gives it. Whenever there is a low demand, it cuts on. So this is also one of the areas where uh, you should always think of. So are different places getting electricity and different places getting used to it. So how best we can give them with the quality power is also one of the areas where the microgrid controller can be uh, used upon, right? So, and Internet of Things. So that's what I was thinking of. So without this, I think the research cannot be complete, right? Research can be happen with respect to the material part, with respect to cell part, with the panel part, and everything. But the one which you have already into the market, and then the panels which you want to understand that the behavior of them and everything, and all these things only come when you have a data of the previous years. How best we can improve it, because it's technology is new, right? So it's not it's just a 3-4 decades old. So if you want to improve the technology, if you want to touch upon the innovation part, and the and understand the future potential of it, definitely this Internet of Things and data analytics should play a vital role. So I think if the AI comes into picture, then definitely Usage of AI has also been thinking of in one of the in plans nowadays. So then if that comes up with, definitely this Internet of Things, definitely IoT definitely will play a vital role. So what does the IoT will do in a plant, right? So it takes the census data collection, it takes the wind data collection, it takes the irradiation level data collection. So everything just have a monitoring point, I mean monitoring equipments. So from all these equipments, it collects it and gives that set whether with respect to this condition on this particular time, whether this our panels have been given a good generation or not. If not, what is the fault? So that is also can be real-time monitoring, and then we can see we can with some formulas we can also assess on the plans which is getting generated. And predictive maintenance, that's what I was stressing upon, right? See, one of the inverters or one of the strings which is behaving odd, then how we are generating, how we want to identify that. So it's only through data, with real-time data, which is real-time monitoring data, which can be seen it, which can be analyzed it, and then it can touch upon the same inverter and go to the same inverter, and then it can cut down the time as well. So and then performance optimization, right? Yeah, this is also one of the areas. So that's where when you have the sensor data of all the things, right? Even the dust, the collection of the dust, even the humidity levels in the one, even the strength of this, the irradiation levels of it. So even temperatures of it, absolute temperatures of it, and all these things. If you can have the combination of it and use it in a formula wise, definitely, I think the behavior of the panels, the behavior of the cells, the discoloration of the cells. There's so many things are there when you go into your plant, right? There will be spots which will come up. There will be excreta of the birds, which will definitely will degrade your generation part. So why it is so? Rather than what you call going around about for all the plants, you cannot roam around 100 acres plant every day and night. So it's only through monitoring, I think you can tap on that. So remote in Andhra Pradesh and in Telangana, and even also in Tamil Nadu to some extent. So all these things, see, there was not that quality of transmission which was not maintained. So whenever we generate and give it, and the way the distribution point should be tapped upon, there is always a difference. An example, if a small plant, if it's getting generated 100 units at your plant level, at your plant point, and it's only 92 units have been recorded at the distribution point, then there is an 8% decrease, right? The tapping of generation, this is also one of the grid integration factors, also one of the issues, right? Transmission issues are there. So distribution issues are also there. That has to be also been touched upon by the governments to to use that the quality of products, so that the energy cannot be waste. The generated energy with a lot of efforts which we put in cannot be over waste. So smart solar technologies and improved grid infrastructure will enable seamless integration of solar energy into the electricity grid, ensuring a reliable and sustainable energy supply. So this is where I wanted to have this in a general sense. So what are the challenges and opportunities which you have? There are challenges, right, with from the cell level to panel level and the design level and everything, and the monitoring level, and also the maintenance level. So intermittence, the inherent intermittence of solar energy due to weather conditions and day-night cycle requires further development of energy storage solutions and grid management strategies. So that is where I was thinking of. So we have only sun hours of 6 with respect to solar you're talking about. Then other kind of technologies also should be think of CSPs and other things, so that you will have to tap this energy and store it so that it can be used further, because the storage is definitely, it's a forte now. It's definitely a fashion because of the electrical vehicles, because of the other commercial electrical vehicles also into the picture now. So this has to be due to weather conditions. I think the different designs has to be used, like in hybrid ones, like hybrid CSP and PV kind of things can be used, so that it can be thermal energy storage, or can be used for generating electricity at the different timings, whether use timings or the peak timings. So it's all, I think there's also challenges which you can use. So land use, large scale solar farms can require significant land area. So when the efficiency increases, for example, say for the efficiency energy yield of a panel, if it is 18 to 22% as of now, 22% already, because all the installed plants, which I said 80-85% of the world installed plans are of yield of an efficiency of just, I can say that 19 to 21% on an average based. So if that efficiency of the panels, if we increase more than 32%, then definitely the land area which we have used for the 85% will cut down by 35%. Roughly, I can say that. So this definitely gives you a more significant factors, because the land valuation is definitely in higher cost as of now in India, but in other areas also it is getting increased in America, because the land area is more, any of the land cost is less. But we can use a lesser land and then more plants. Definitely, we can generate around 30 to 35% more than the same land used for the earlier plants. So what are the environmental impacts? Careful planning and responsible development practices is also essential for this land use also. So this is, I think, design's point of view. I think being an engineer, I think I understand that where are the points which you can touch upon, so that we can use the resources or the available products to the maximum extent and to the proper extent and to the quality extent. So investment and policy support. So this is initially the people have come in India. If you can say that, it's a funny thing that, yeah, they have come because when there was 90 to 90% subsidy given to all the states, when subsidy has cut down, the number of plants which is getting installed has been reduced. And so the urge or the importance have come down drastically. So the investment, they're not thinking of the investment point of view. So this investment word, I think it has to reduce, and social responsibility also should be part of it. And also, let's see, the break even earlier was 3-4 years. Now it has increased to 7 to 8 years. The people are not willing to invest there. See, if you are spending on 100 crores, the people have to wait 7 to 8 years to get to 100 crores back. That is the break even, right? So that's where the people have been taken a back step. But the government has to, the policy has to be supportive and encourage this renewable energy sources to cut down the fossil fuels, because fossil fuels, then you have 2040, 2050. I think this is a diminishing factor. And definitely, especially if you can think of Telangana area, I think 2050 will be the time where the coal will be diminished from the Singareni collieries. So there will not be no coal. So if that is the case, then where you will rely upon? That is also one of the criteria which you think of as an individual and as an investor point of view. Also, the investor should have social responsibility also to be part of it. So by overcoming these challenges and embracing the opportunities that lie ahead, solar energy can play a vital role in meeting the growing global energy demand while mitigating climate change and building a sustainable future. So that's my intention was, as a responsible citizen, as a responsible energy person, which has been close to it for about 12 to 14 years now. I always see that, rather than thinking of that, mujhe kya hai, mujhe kya milega. That's a word we can use it. So if you can use that, hame kya milega. That is the right word to use it. And the responsibility also should be a part of it, and then to go ahead on this innovativeness. So I think I have touched upon few of the points because of the technical aspects of more. And I hope, I think I've given you some insights of it to research upon, to think upon, to understand the solar energy, the innovativeness, and the future potential of where we can be part of this as a growing and as a knowledgeable individual citizen. And hello.
Yes, sir.
Thank you, sir.
Right. So thank you, and I think I made
On behalf of Maulana Sahib National University, the organizing committee of this faculty development program, and all the participants, I would like to propose a vote of thanks to Dr. Shashi for such an inspiring and informative session. Thank you so much, sir.
Yeah, thank you all for giving me an opportunity to talk and all this with respect to this knowledgeable persons like you. And definitely these points which I have given you, definitely there are some individual areas where there's so much of scope, because you're into the polytechnic colleges, you're young and energetic now. I think you just think of each topic which I've touched upon, and there's several other topics, not only this, several other topics which you can research, and there's so much of material in the net. And then whenever you feel like understanding, right, whenever you feel like talking to me, or you can always approach me to the email ID, which I think Ajra Fatima can share it, and I should have kept it in my slide itself. So I think you can approach me anytime, and then what best I can do from my end in order to young minds, ignite the young minds, definitely I'll play my role in this. Thank you very much for that, for all the participants and listeners to calmly listening without any interruptions in between. Thank you very much.
Thank you, sir. Thank you so much. So, dear participants,